Okay, this is just a quick video to explain what coterminal angles are. Up to this point in your math career, you've probably dealt with angles from 0 to 90 degrees, or maybe it was 0 to 180 degrees, or talked full circle at 360 degrees, but probably not talked about larger angles. What happens if we go around past 360 and then stop somewhere after that? Well, a coterminal angle are angles that share the same terminal side. So all four of the pictures given here all have the same red line on them. We're going to assume they all have a 35-degree angle as their terminal side. So this first angle, as you can see, goes from the blue line, your initial side, to the red line, your terminal side. And if you head directly there, counterclockwise, remember being a positive angle, always good to remember, counterclockwise equals positive angles. Okay. That's a 35-degree angle. Now in the second picture here, as you go around the circle once, we're traveling 360 degrees, but then you're traveling again in an extra 35 degrees to get from the blue line to the red line. So grand total, the angle you've traveled through is a 395-degree angle. So 395 and 35 degrees are considered coterminal. If you travel 2 times around, again you're going 360 degrees, but you're doing so twice, and then traveling that additional, again, 35 degrees. So 720 plus 35, this entire angle all put together, round twice, plus the extra, will be a 755-degree angle. Again, considered coterminal with 395 and coterminal with 35. The next picture, notice we actually went backwards. And if you travel a clockwise angle, well, if positive is counterclockwise, then this is considered a negative angle. So we're essentially taken 35 degrees and subtracted off a full circle. Or if you consider the red line and backing up all the way around, but we didn't travel that initial 35, you will get an angle of negative 325 degrees. Also considered, again, a negative then coterminal angle with the other three. All of the angles are drawn in standard position. You'll notice that initial side and terminal side are all at the origin. And that's how we'll draw most of our angles for these next pictures. So take a second and think about how could you find a positive and a negative coterminal angle for each angle. Remember, just adding on a full circle or subtracting off a full circle. Again, meaning that your final answer comes up either positive or negative. So really you could do either one of those depending upon your angle. Then also try drawing them in standard position. Go ahead and pause the video now and try it out. Okay, for just the first example, you'll notice I took 215 degrees and added 360. So my 575 is coterminal with 215. And then I also took 215 degrees and subtracted 360, ended up with a negative coterminal angle of negative 145. Now in order to draw the picture, again, it's always helpful to think about your quadrants. Remember, a 90-degree angle is just our first right angle, or basically your positive y-axis related to the positive x-axis. 180 degrees is a perfectly straight line. 270 would be pointed straight down, so again traveling from that positive x-axis around to that point. 215 falls in between those two. It falls in between 180 and 270. And actually you'll notice that it's 35 degrees, exactly 35 degrees past 180. Since 45 is about halfway, I'm just going to try to make my line a little bit higher up, not quite 45 degrees, but a little bit farther up to the left, closer to 180. Then we just have to note that we started on the positive x-axis and traveled around to our line. And that's a good picture. With 785 degrees, that's such a large angle that I believe if we just subtract 360, we won't have to add 360 at all. We can just subtract our 360, end up with a 425-degree angle. Fix that up there real quick. 425-degree angle, which is a positive angle. So there's a positive coterminal right there. And in fact, if we just keep subtracting, subtract another 360, we should be able to end up with a fairly reasonable angle to help us graph, as well as if we subtract one more time to negative 295 degrees, then we'll get our negative coterminal angle. Remember, the final answer needs to be positive or negative. I'm actually going to take advantage of my 65-degree angle, being that I know that's between 0 and 90, and it's actually a little bit closer to the 90. It's going to be up this direction. All I have to remember, though, is for 785, we had to subtract 360 twice, so we actually need to travel around 360 is 720, and the additional 65 to make our picture there. Since negative 400 is already in the negatives, again, we can at least try adding 360, and notice we'll end up with a good negative coterminal angle already, so no need to actually subtract. And if we do that one more time, you can get your positive 320 degrees. There's a positive coterminal angle. And again, the negative 40 is fairly easy to use. For negative 45 degrees, remember, it would be going clockwise 45 degrees. So we want to be fairly near there. And again, to take out any question, after we fix up that picture a little bit, the arrow didn't look too great. This is a negative 40 degree angle. As long as you label it and it's reasonably accurate, that's a pretty good picture. The last thing I want to discuss is what if we're talking about radian measures. Remember, radians are just a different way to measure angles. A full circle in radians is 2 pi. So in order to find coterminals, that's exactly what we're going to add, as well as subtract to find our coterminals. Now, in order to do that in fraction form, we need to remember that 2 pi is equal to 10 pi over 5. Remember, 10 fifths would be 2, or if you multiplied top of this and bottom of this fraction by 5, we'll get our common denominator. So 12 fifths plus 10 fifths will be 22 fifths of pi. And since 12 minus 10 isn't going to be negative yet, what we can do is, instead of subtracting 2 pi, let's go ahead and subtract 4 pi. 4 pi being 20 pi over 5. So 12 minus 20 being negative 8 pi over 5. Now, knowing that 2 fifths, 12 minus 10 would have been 2 fifths, is a good remainder to have, because 5 goes into 12 twice. We're going to travel around to pi and back to 2 pi with an additional 2 fifths, which is just short of a half. So if you think about chopping your full circle, right, into 5 parts, right, we're just going to that second of those parts, if it helps you think of it that way. I think that's probably the easier way to form these graphs. So go ahead and pause the video and try that on our second angle. Note that it is a negative angle, but take advantage of the fact that 3 goes into 17 5 times. Okay, and to do coterminals again, like we said, we're going to add our 2 pi on. So 2 pi equals 6 pi over 3. So I added 6 pi, got a negative 11 pi over 3. It's a good negative coterminal. Did it again, still negative, so did it one more time, and ended up with our pi over 3, which essentially means in order to graph this, our terminal side is going to be at pi over 3. So remember, if we chop pi, a straight line, into 3 portions, essentially about 60 degrees, 120 degrees, and 180 degrees, the first of those portions is going to be our terminal side. So now all we need to do is remember we're traveling negative 17 pi over 3. 3 went into 17 5 times. So let's start out by saying we're going to go negative 1 makes 2, makes 3, 4, and 5 with an additional 2/3. The remainder of there would have been a 2 over 3. So 2/3 of pi. I hope that helps you graph your angles. Remember that in degrees, a full circle is 360 degrees. In radians, it's 2 pi. That can help you with your coterminals. And I hope graphing goes well for you. Happy trig!